Hi, in this presentation we will look into the circuitry inside the basic boundary scan cells. After watching this presentation, you should be able to explain how the circuitry inside the basic boundary scan cell is able to control and observe any functional pin, and you should also be able to explain why these boundary scan cells have little or no importance during normal circuit operation. In this slide, you see a representation of the basic circuitry that is inside each boundary scan cell. You can see that it comprises two small multiplexers and two flip-flops. We have two stages, the input stage, which is also called the capture shift stage, and the output stage, which is also called the latch stage. When we power up the circuit, this is how the output multiplexer operates. The parallel input of the cell is directly connected to its parallel output, and consequently all the cells are in transparent mode, meaning that all the pins are connected to the core circuitry. If the input multiplexer is set to capture mode, as shown now in the slide, the flip-flop in the input stage will capture the logic value that is present at the parallel input at the next rising edge of the test clock. All the cells operate in the same mode and they all receive the same test clock. Then, by switching the input multiplexer to shift mode, we set up a serial path that goes through the entire printed circuit board. So we can actually shift out the values that were previously captured at the parallel input of each cell. This means that we can alternate between capturing the values at the input pins and shifting them out for observation. By capturing the logic value at every pin, be it inputs or outputs, we are taking a photograph of the circuit condition at that moment. Then we can switch to shift mode and shift it out, and then take another photograph and shift it out. And by repeating this operation, we can actually build a movie that describes the operation of the circuit. And notice that this can take place while the circuit is operating normally, since in this case the boundary scan cells are in observability or transparent mode. The other operating mode is the controllability mode, sometimes also called test mode, where the output multiplexer in the boundary scan cells isolates the core logic from the pins. As you can see here, the output of the cell no longer comes from its parallel input. And of course, we can also alternate between capture and shift while the output stage is in test mode. So testing a board starts with the test cells in transparent mode, as we saw in the previous slide, followed by setting the input stages to shift mode, and then shifting in the first test vector. In the case of the short circuit shown here on the top, we might shift in a 1 to the boundary scan cell driving the upper interconnect, and a 0 to the following cell, such that the two interconnects are driven to opposite logic values. These logic values will be stored in the output stages of the cells, but they will not be visible at the output pins while the test cells are in transparent mode. So the next step is to set the output multiplexers to the controllability mode as shown in this slide, and that's when the fault detection conditions are driven to the output pins. The next step is to set the input multiplexer in every cell to capture mode as shown now, so that the test responses will be captured at the next rising edge of the test clock. And finally, the input multiplexer is set to shift mode, and by driving a number of test clock pulses that is equal to the number of boundary scan test cells, all the test responses will be shifted out. Notice also that while the test responses are being shifted out, we may simultaneously be shifting in the next test vector, and so on until we have gone through all the test vectors and test responses. And that's it for the boundary scan cells. Thanks for your attention.